Hello, my name is Angel Feliciano, and this is my video explaining programming assignment number two. Sorry I'm sending this in late as I sent in programming assignment number three beforehand. That was my mistake. But to get right into it, this is basically my program. In this program, we were comparing the FCFS algorithm versus the SJF algorithm and the way that the CPU schedules them. And in this assignment, I did use a little bit more of AI help than I usually would to help me just go through the logic. I thought that was the hardest part about this was basically coding out the logic. But I mean, the math is the same and is very similar to, basically the way that we calculated by hand and by pen and paper, like how we did for the midterm. So this is the way I decided to start the program. I brought in the input output library along with the standard library, and I defined the max number of processes to 100. The next thing I had to do, which I saw that a lot of people had done when I was reading the discussions, was basically define the struct for the processes so that way every process has the same characteristics of process ID, the arrival time, burst time, waiting time, and turnaround time. These are the four essential traits that every process has when they're running on the operating system. The next part that I moved on to was gathering the information for the for the processes. Basically, asking the user to enter the amount of process they want to create and to scan for those, and then as well as a for loop going through it for each process, basically asking for the arrival time for that process and the burst time for that process, and that would go storing it inside of this process array of type integer. So then after that, we're gonna start calculating the times using the first come first serve algorithm. And this function takes the process array that was created over here and passes it into here. And the first thing we have to do is initialize the time to 0, and then also we create the total waiting time and the total turnaround time for the first come first serve process. Basically, you know, this would show us, depending on the processes, their arrival times and burst times, comparing it to the shortest drop first and this one. This would be basically the amount of time that it took, and comparing this one to the amount of time that the shortest drop first one would do. Then we could see which one was better for that set of processes. So for uh, here basically begins the first come first serve scheduling. We do a basic loop where if the time is less than the arrival time of the process, then the time is equal to the process number's arrival time. Then we're gonna get the waiting time for the process, where it's gonna be basically the time of the arrival of the process, or rather the actual time versus the arrival time, which will give us the waiting time. Then we can add the burst time to the total time because that's the amount of time that it takes for the process to basically work itself out. And then here we have the turnaround time, where it's going to take the waiting time plus the burst time, which was how long the process had to wait for and how long it took. And that's going to basically make the turnaround time, which is the total amount of time that process needed to operate and work out. So then we add it to the total waiting time and the total turnaround time. So that way we have basically the final numbers for the first come first serve algorithm for us to then compare against the shortest drop first. 100% the Gantt chart was made with AI. For the Gantt chart that I usually make in Mermaid, I didn't. I saw how other students were kind of incorporating it into the program, and I like that a lot better than using it in Mermaid. But it was super curious on how to make it, so I basically did ask ChatGPT to make it, and it basically just created a table where we have the process IDs and the arrival times, and basically just a table like how the CPU scheduling calculators online work. So then this is the one to calculate the shortest drop first, and here we have the function for that, which is also going to take in the process array that we created above. It's going to ask for, the completed processes, the time, and the shortest process, which is going to be stored as -1. We make a minimum burst time for the program, because if sometimes jobs are very short, this number is made big on purpose, uh, because anything that is greater than this will be set as the new shortest job. So then we have the total weight and the total turnaround time as a float, so that way we can get it down to the decimal. And then this is the complete processes array, and basically we started with 0. We started with a while loop where completed is not going to be equal to the number of processes that are going to be counted. We have the minimum burst again, equal to 1 to the 9 zeros after it, making it a very big number, and then setting the shortest to -1, essentially just creating a baseline for the shortest process. Next, we're going to iterate through the loop, and while it's not complete and processes arrival time is less than or equal to the total time, and the process burst time is less than the minimum burst, which we set over here, uh, we're gonna get a new minimum burst of the process and its burst time, and then we're gonna set the shortest to that number in the array. If the shortest is equal to -1, the time is gonna be incremented by 1, and we're gonna continue on to the next process in the array or in the loop. Once the loop is done iterating, we're gonna end up having to do the same logic for calculating the waiting time, burst time, and turnaround time. And then once we do that logic, we're gonna have the shortest time set to 1, which is gonna ultimately just like not let this go back to the top, and then we're gonna increment the completed section. The total wait is gonna be equal now to the waiting time of the shortest process, and then the total turnaround time, same deal. And then we're gonna print that out here. The Gantt chart for this one is gonna be exactly the same as the top one, so I basically just copied and pasted it down. And then my main function is just the process with the max processes in mind, taking and then running the functions in order with the input process, the first come first serve, and the shortest job first. So some things that I was debugging when I was working on this was that basically I was getting errors in the shortest job first function when I was coding the logic. Everything started to look similar to me, and it was really bugging me. I had the variable for complete and completed with the same name, and it wasn't working, even though I had this as an array and this one as a normal integer, or just an integer variable, and it wasn't compiling at all, and it was giving me an issue. Another thing that was giving me an error that ChatGPT called old buggy version, I was a little offended by that, was that I had the shortest comparison equals to -1 inside the for loop when it should have been outside of the for loop. And then here it brought it out and made it its own thing. Outside of that, those were kind of the personal problems I had bugging. I did take a while doing this assignment, just being guided myself through it, and I think that it was definitely a lot harder for me to understand how to make this one out. But once I was done, I was like, wow, this was not that bad at all. But it's not compiling in my VS Code, so I'm gonna compile it here in this online C compiler. I know that on my Mac I'm able to compile it from the terminal, but the extensions for some reason don't work on my computer. But that's something that I have to fix another time. So I basically compile it here to make sure that everything is working. This is the same exact code that I have in the VS Code, and then here it's gonna ask me to go through the process creation. So I'll do 3 processes, and then I'll do some arrival times. Oh, and then I have a segmentation fault. But it did compile, and I have to go back and fix that. But yes, this was my code for the programming assignment 2, and I hope that it can explain well exactly how the first come first serve algorithm works and the shortest job first algorithm works as well.